Welcome to Mr. Mac's World of Physics. I hope to use this video to basically demonstrate one of the basic laws of physics called an inverse square law. What I'm going to do is use a discrepant event to do that. So what I have is an inclined plane that's curved. I'm going to put a metal sphere at the bottom. Right, going back to previous understandings of physics we've had, we realize if I release the ball from the top, it should roll down, strike that ball, and due to conservation of momentum and kinetic energy, that ball should roll up the incline as the momentum of this ball is transferred to the stationary one. There's going to be a few little problems with that. We're going to have some friction, so we're going to lose some of the kinetic energy, so this ball will not roll up as much. We'll also hear a clanking, which means some of the sound went off as kinetic energy, and the ball will probably gain a little heat. So we won't get a total transfer of energy to there, or kinetic energy. We'll have what we call an inelastic collision, or a partially inelastic collision, in which case some of the energy is lost to other forms. However, the momentum should be transferred. So let's just see what happens. We roll it down. All right. Again, because it's curved, we don't have that nice straight transfer, but we do see an effect. If I roll another one, you might see a little bit better. And let me roll a third one down. All right. So in this case, again, we can see transfer some of the kinetic energy. We can see basically the ball's reaching mechanical. Well, I shouldn't say that. Basically, we're going to transfer the energy. All right, what I'd like to do is reset that up one more time so that we can demonstrate another concept. And that is a discrepant event. All right, after doing this many times, we may have noticed, whoops, that was inappropriate, me to stand there. We would have noticed that when the ball rolls down, it suddenly transfers its momentum. So let's try it one more time. All right, that is a discrepant event. Suddenly we saw an acceleration. Where did the extra energy come from? Well, that's part of the things we're going to look at. So let's take a closer look and see what we can see. All right. Okay, so let's roll this one more time. We again through the three spheres there, and I'm going to roll one down starting from the top. All right, that time what did we see? We saw it shoot out at a much higher speed. All right, the question becomes, where did it come from? Well, this might give you a hint. In the last case where you saw the acceleration, what I did was replace one of the spheres with a magnet. What the magnet does is exerts an extra force. Before it was just gravity carrying them through. Now there's gravity plus a magnetic field. Right. What the magnetic field is going to do is going to demonstrate the concept of an inverse square law. Basically what I did again was take one sphere that's not magnetic, another sphere that is not magnetic, it's not magnetic, add the third sphere, which is magnetic, and put them in place. Right, I have the three spheres, one magnetic. The magnetic sphere is the one on the end, and these two are non-magnetic. When I roll the next sphere down, it should come in here and strike the magnetic sphere. However, because the magnetic sphere is there, and the sphere coming down is a metal, a magnetic metal, it will then attract that, causing that magnetic metal to accelerate. However, the momentum when the collision occurs will be transferred from the magnetic sphere to this one to finally that one. However, the inverse square law tells us that the strength of that magnetic field will be inversely related to the square of the distance. What that means in plain English is that if I double the distance away from the magnetic field will decrease by a value of 4 times. So basically, as I roll this sphere down and it hits, it's coming in contact with the magnet. Therefore, all the energy transferred here needs to be transferred through here to the last sphere on the end. However, the force holding the sphere in is 1/4. The force holding that in. As a result, you'll see an increase in the speed, because this will speed up, gain a tremendous amount of force, or in this case energy. That energy will be transferred through them, and then the force holding this is weaker so that it can go off with more of the energy. Let's see what happens if I add another one. You'll notice that both of these were equally distanced, so they held together strongly. Well, let's just do it in sequence then. Let's try one at a time. I do one. I do 2. I do 3. I do 4. Now, can you predict what's going to happen as I add the magnetic sphere, and you can predict why? All right, so you ready? Let's see what happens. Now again, non-magnetic, 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 and now this is magnetic. I'm going to go and repeat the experiment, and can you again predict what's going to happen to this one when the other one comes in? And can you explain why? We ready? Okay, I'm sorry, I think I misexplained which of the ones were. Again, in this case now we have non-magnetic, non-magnetic, magnetic, and non-magnetic. All right, can you predict in this case what should happen? Let's take the one off the end, which is non-magnetic. So now I have non-magnetic, magnetic, non-magnetic, and non-magnetic. All right, magnetic, non, non, non. And let's try one more time and see if we can again predict what should happen. Okay, just a quick review. 4 non-magnetics. The magnetic one will come in. It will accelerate, increasing its kinetic energy, so it should send that one flying off at a very high rate of speed. Okay, recap again. Non-magnetic, 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 magnetic. We're going to add the other ball in. We will notice that when this hits, this one is going to be 3 times further away from this one hitting. So all the gain in kinetic energy here will be transferred to there. However, the force holding this one should be 1/9 the force of the one closest. So let's see what happens there. All right. Non-magnetic, non-magnetic, magnetic. Okay, so non-magnetic, non-magnetic, magnetic, non-magnetic. This time when I add this in, you will notice that this will accelerate again, pulled in there. But the force will be equal to, the force holding this in will be equal to the one holding the far one in. And we should see an interesting thing. We did see this move away, but we saw it pulled back. All right. The force here was not very great, the magnetic force, because it's twice the distance to the original one, so it didn't accelerate as much, transferred some energy away, but it pulled it right back. All right. By again moving the magnetic one further down, we're going to not have a much increase in the kinetic energy as I roll to that, but we should see again the transfer of kinetic energy, but we should see this one held very strongly by the magnet. And being that they're all there, we're trying to move the whole mass of them. Hard to do.